In this video, I'm going to give you some suggestions to help you with your calculating moles, mass, and number of particles assignment. On the page, the main page for Module 1D, which looks at the mole, there is a handy map that you may wish to include with your data tables to use with your assignments. So what I'll do is I'll show you how to use this particular map. I can see from your work that you prefer to solve things ratio style. That's awesome. So here's one suggestion that I would change about your map. On the map, I've used the formula in the box strategy to give formulas on how to calculate mass right here and how to calculate moles right here. So what I'd suggest you do is take that formula in the box off if you want, and then add the following information. In order to go from moles to mass, we must use the variation of molar mass, where you have your number in grams over 1 mole. But if you want to go from mass to moles, you're going to use the inverted molar mass, which is going to be 1 mole over so many grams. The reason why I put this number in X is because you're going to have to calculate it. For example, here in your question 1A, you have said that you have 28.0855 molar mass of silicon. Well, that's the number that's going to go in here. Sorry, I have to pause and figure out why I can't write. Okay. There we go. So 28.055 grams would go into this spot where X is. With any particular question, you're always going to have to find molar mass. At this point, since you've already been given a lesson about molar mass, chemistry kind of assumes that you know that, oh, you have to go back to your periodic table and calculate this. So I would suggest making that change. It is totally legal to use your map on a quiz or a test. Okay. When you report answers, you must use all your rules of significant figures that you've learned. In your first question, 42.6 has 3 sig figs, 1, 2, 3. 28.0855 has 1, 2, 3, 4, 5, 6 sig figs, which means you need one more digit because you have to have the same number of sig figs as your least accurate number. So the correct answer in sig figs is actually 1.52. For question B, you have 24.5 grams of zinc divided by 65.38 molar mass, and you have a calculated answer here. The number 2.45 has 1, 2, 3 sig figs. The number 65.38 has 1, 2, 3, 4 sig figs, so you actually get 3 significant digits here. So the correct answer is 0.375 moles. In question 2, you've tried to use the same version of the fraction in order to solve for number of particles. You are starting off with moles here, and you are finding out the mass, which is down here. So you're actually using this variation of the formula. So here's what that's going to look like. You're starting off with 300 moles. You are trying to find grams per 1 mole, and you have determined that the molar mass of sulfur is 32.065 grams. Without worrying about numbers, I'm just going to show you something here. Excuse me, I'm just going to shut this off. Okay. Let me try this again. I'm just going to look at units here. If I go moles times grams divided by moles, moles divided by moles is equal to 1, and that leaves grams. With the way that you did your question, the units are going to look like this. So in your question, you said moles divided by molar mass, which is grams per moles. So the way that you've tried to solve the problem, you're going to end up with moles squared per grams. That's, as far as I know, not possible. This is going to lead you to a very different number than what you've... Oh, wait a minute. So I'm going to pause the video here. You've actually indicated the correct answer here. So you've indicated that the number is 9,618 atomic mass units or grams, but you do not have the correct number of significant figures in this particular answer.